I'm Fung, a climate modeler from HK USD, together with me, Professor Charles Wang. Today, we are going to share with you how climate science and the development of fine-scale climate modeling is evolving in the era of advanced technology. Climate change is not distant away. It is happening now. It is affecting every aspect of our life, our economy. But as a climate scientist, we are not just observing. We are looking for solutions and what we can do. Let us dive in. Now, how climate scientists predict future climate change in the globe? So we follow different socio-economic pathways, from sustainable development to business as usual to heavy reliance on fossil fuel. Based on each one of these pathways, we can estimate the amount of greenhouse gas is emitted into our atmosphere, such as CO2 or methane. We also taking land use changes as well as human activity into our account. Armed with all this information, we put it into a computer model, basically solving a set of partial differential equations. So the current climate model basically divides the globe into a square grid. Each one of these grids is about 1 kilometer resolution. And then we do it in the computer simulation, project our climate hour and hour, year by year, to project, okay, in the next 70 years, what is going to happen? Now, but the catch is resolution, because a lot of the extreme event is not happen in a 100-kilometer resolution scale. A lot of them is happen in a much finer scale in your neighborhood, at your street. So the current global climate model is a bit like a picture is very blurry. Each pixel is, as I pointed out, is 100-kilometer resolution. So it's a bit like if you're asking whether it is going to rain tomorrow, and the only answer you get is it's going to rain somewhere in southern China, so as is shown in the middle panel. This is not very useful information. It's not very actionable. Instead, a climate modeler using a technique called regional downscaling basically is zooming in to produce from a very blurry picture into a high-definition 4K movie, like in your right-hand side picture. Now we can tell, okay, for this particular picture, tell you, okay, where is the hottest space in Hong Kong? So whether it's in Central or in Saigon. Now let us talk about extreme, okay? To predict where and when the extreme rainfall is going to fall, it's not going to be easy. Okay, it still is one of the hardest things to do in climate science. So if you still remember the rainfall event in early August, it started to rain very heavily, but suddenly around in the evening of August 4th through the day of August 5th, extreme rainfall hit without advance warning. Okay, nobody expected the rain will be that heavy, last for that long. Okay, this is highlighting the limitation of our current atmospheric model. Now, this is the data. Let us looking more on the extreme on this so-called the highest daily rainfall event. Okay, since the record began in 1884 until this year, 2025, 141 years. The data show you, okay, 4 of the 11 highest daily rainfall events happened for the last 5 years, as you saw on the red bar. Okay, that means extreme event is happened more often. Okay, recently for the last 5 years, it's virtually on a daily basis. Now, if you look at on an hourly event, okay, yet again, it's the record from 1884 until now. Okay, you can see as the year go by, the highest hourly rainfall event is keep breaking the record. The highest event now is 158.1 millimeter per hour, happened in 2023, which is the event flooded our Wang MTR station. Now, our projection actually say by the middle of this century, the hourly rainfall is 233. By the end of the century, the extreme rainfall value is nearly double. Now, if you look at our PDF, okay, about extreme rainfall, it actually tells you the extreme rainfall event is happen more frequent, more intense, as you saw in the red arrow. You can see the red arrow is keep shifting to the right. That means the extreme event is getting higher and higher as the year go by. Okay, now whenever we have extreme rainfall, very long time, slope safety will be a concern. And I would like to invite my colleague, Professor Charles, to tell you something about slope safety.
Good morning, ladies and gentlemen. After listening to our top scientists telling you about future climatic events, particularly heavy rainfall, you may wonder how his prediction affect your life, affect your family, affect your business. Okay, what's the risk of your home? So I'm going to share with you a couple of slides. I can assure you highly relevant to everybody in this room and everybody on this planet. Landslide and debris flow can be deadly, and this was picture taken on the 1st of May 2024, killed 51 human beings. And let me show you quickly how devastating of landslide and debris flow can be. And you can see that happened in Brazil. It's horrifying, isn't it? Anybody know Korean can translate this? Okay. So our top scientists telling you those are all rainfall-induced landslides and debris flows. They are not due to earthquakes. And think about your business, okay? And particularly for industrial sectors, insurance sectors. How are you going to insure? Okay, how are you going to set your premium? And this is in 2019 in Fujian province. Think about you are insurer. How are you going to set a premium? In Japan. Okay, this is in Peru. Maybe let me just speak. Okay. So we have to prepare for it. Not just as a scientist and engineers, but also for the entire society. And according to our top scientists' prediction, okay, by the end of this century, our rainfall, and this is for Hong Kong, of course, is going to be about doubled. Then what will be the consequences, and how are we going to prepare for it? And I'm going to share with you my university. Recently, we just established this as the world's largest testing facility. To do what? To study impact mechanism, preventive measures, and also to verify risk, okay, maybe imposed to different sectors, different industry. Okay, let me quickly show you a video. How does it work? So this is a huge facility, and as I said, only one in the world can help us to study how the debris, resisting barriers can protect us, and also assist the particular insurance industry how to assess adjacent areas in terms of premiums. And we can provide also risk map for the intended protected regions. So you can see the debris coming down, okay, and hit the first and second barriers, and then by collecting data, we can do our analysis and produce a risk map. Okay. Again, let me speed up. Okay, other technology we have developed, and these are state-of-the-art in situ real-time monitoring system, airborne ground radar and everything. So we can monitor the entire area real time, the importance of real time. Those data will be fed into our control center and help us to provide early warning system. And of course, that also coupled together with the latest, that's on the top right-hand corner, that's our environmental chamber, which can be used to simulate different climatic conditions, such as wetting, drying, heating, cooling, rainfall conditions, and so on. So by combining the live, real monitoring data together with science and engineering we learn from our environmental chamber, then add on latest AI technology. So we can come up with a hybrid physical data driven. The important keyword is real time, early warning to everybody. And for the insurance sector, you can think about it. If somebody can tell you, say 2 days, 1 day, 5 hours, what's the risk in that region? And that, I think that would be very helpful, not just save humans' life, but also will assist the particular insurance sector to set your premium. And that's, I think, all I would like to share. Thank you for listening.
A little bit more. Now, of course, climate change, also another issue about climate change is the polar ice as well as the glacier is melting at a much faster rate than previous scientists predicted. This will directly lead to sea level rise that will pose threats on our coast. Now, also low-lying area in Hong Kong, as it demonstrated in this figure, the red and orange area, also actually vulnerable to storm surge. Now, of course, climate change is not just water. We are also facing rising heat. Extreme heat, extreme hot days is going to be dangerous to outdoor worker, lost productivity. It also affects our health, our well-being. So in particular, in the tropic, with rising temperature and rising relative humidity, it actually feels much hotter. For example, this figure demonstrated when the ambient temperature is 35 degrees, you actually feel about 50 degrees in heat stress. Now, our data also show that the hot day is not only getting longer, getting more intense, the heat wave getting longer. If you can see in the middle panel, the number of hot days actually is about 2 months. But by the end of the century, the entire whole summer, 5 months, would be extremely hot day. Most of us would not be there, enjoy the hot day by then, but our children would. So as a result of that, that's why we are actually developing the next generation of high-resolution climate model tailored for the tropic and the subtropics, so that we can be doing a better prediction for this region. Of course, we also rely on AI technology. We are also very, very happy to working with the UN, develop this early warning system for all to warn general public, because early warning would save life, minimize damage. In summary, basically in HKUSD, we are developing the next generation of climate model. Hopefully, we'll be able to predict this extreme event with enough lead time and with better accuracy. With that, I think I better stop here. Thank you.
Thank you, Jimmy and Charles. Very insightful. We would now like to invite Ms. Christine Low, Chief Development Strategist at the Institute of the Environment for HKUST, to the stage.
Maybe you can take a seat at the two end seats, the other side. Yes. May I invite the other panel members to come on stage as well? I'm Christine Low. I'm greatly privileged to moderate this panel, and thank you to my two colleagues for sharing in a very brief way what's happening in terms of climate work and climate predictions. Maybe you can, just doesn't matter. As much as you can, don't worry, just, yes. Well, thank you so much. Let's get right into this. And maybe I can come to you, Debra. Debra is with China water risk, and I have been reading your research over the years, and I think you're one of the first people to link sea level rise with financial risk. So, I mean, Jimmy didn't have time to really talk about sea level rise much. I mean, how do you look at the physical risk?
Thanks for that. Nothing like the first question. So I'd just like to sort of say that we're now CWR because we actually think that China is quite on top of their water risks and have been for a while. So as you can sort of see from Jimmy's and Charles' presentation, a lot of the risks are actually water related. Actually, how we're going to feel climate change is through water, whether it's humidity, sea level rise, and so on. I like the fact that Jimmy showed a picture of ice, because it's one of the topics that I think we're not talking about enough, because it's so far out of sight and out of mind. Just to give you an idea of how fast ice is melting, we're really looking at 50 million tons of ice every hour for the last 30 years. And this is only going to sort of speed up. And this is why the rate of sea level rise has actually doubled in the last 30 years and still accelerating. Now, I unpack all these complex science into kind of like easy to understand ways, right? So I want you to imagine this. Imagine that sea level rise was previously driven by something called ocean thermal expansion. It had 50% of the market share of driving sea level rise. So ocean thermal expansion, 50% market share. Then, and that was during the IPCC. So when the IPCC report came out, 2021, 5 years ago, 50% market share of sea level rise, ocean thermal expansion. Today, ice sheet and glacier melt is the fastest driver. So ice has basically usurped ocean expansion's 50% market share and taken the lead in driving this in 5 short years, right? So now what we're observing is that ice is, clearly ice melts when it's hot, right? I mean, we all know this. Ice is actually now very sensitive to warming temperatures, and 1 degree is now too hot for ice. When we came out with ice fact sheets unpacking ice risks for the financial industry, and we did this with the Chinese Academy of Science, the Chinese National Committee for Cryospheric Sciences, as well as the International Cryospheric Climate Science Initiative. And these are guys that write the State of Our Cryosphere report. And since then, at that time, 2 degrees was too hot for ice, and now they're sort of saying, and that was March, now 1 degree is the safety margin for ice. And today we're at 1.55. What does this mean? This means that we're now on track for 1 meter of sea level rise before 2070 is possible, which means it's going to be 2 meters by 2100. And if we downscale this to Hong Kong, that's 2.5 meters by 2100. We did a stress test of 195,000 assets in Hong Kong to a 5-meter grid. It doesn't look good. Sea levels will be at HSBC, OCBC, Standard Chartered, and so on, right? We'll lose a lot of central. So we need to step up adaptation. So with great risk comes great opportunities. We need to rapidly decarbonize, and also will open up a lot of adaptation opportunities. And obviously, a lot of AI. We need a lot more research to sort of see how we can actually sort of like deal with this slow but fast-moving risk.
Great, thank you. Well, perhaps Ma Qing, I can come to you. You know, from Siemens, you've heard Jimmy and Charles talk about the kind of technology that we're using, AI and many other digital and other technologies. So as one of the companies with lots of technology, how do you look at the kind of data science and data technology? How can you contribute to this?
Well, I'm very impressed about a lot of insights that's shared today. And we heard a lot about challenges. And now we really need to find solutions. And Siemens is a technology that truly bring and connect the digital and the real world. And we are also the front runner in AI. And we deeply believe technology, particular AI, play very important roles to unleash the power of the technology to address all those challenges that we talked about. And Siemens, we have a comprehensive technology stack, and the software and hardware technologies, our digital twins, and our software-enabled automation, electrifications, all this can support our society and our industries stay resilient and sustainable. If you allow me to give a little bit elaborations through 3 angles. In terms of energy resilience, that basically we need to answer, is our energy system, the power supplies, the distributions, the network, and the grid that still can keep working when we have the climate challenges, when the extreme weather conditions that we have to deal with. So AI here, we all know, that the weather patterns is usually very, very hard to predict. And, also the energy challenges is also how to manage the supply and the demand. And AI here play a very important role, that we have AI-enabled smart energy management system that can diversify the energy mix and able to also find a solution to prepare the energy backups, the options to prevent the outage, and particularly also improve our energy efficiency. I think efficiency is also resilience, right? So that's energy resilience. If you talk about resources resilience, it's basically we need to make sure that we have enough bases, the food, the clean waters, the materials, when we're facing the climate challenges. Can we keep the daily life maintained? Can we make our operations in the in the manufacturing, infrastructures, and public service that keep working? And there we have also AI-enabled predictions, analysis, so that we are able to provide a lot of simulations. So that's what I would say the resilience about resources.
I'm going to come to you later, Jimmy, but I'm going to let you think about this, because you and I have had many discussions about AI. AI is great, we know that, but you're going to tell us later in climate modeling what AI cannot do yet, right? We'll come back to you later. But before that, Brad, maybe I can come to you. Brad is with the United Nations, the International Organization on Migration. And so I know you take a community view. Perhaps you can give us a perspective from the UN.
Sure. Thank you so much, Christine. So, yeah, I want to talk briefly about how we use this data, right? In particular, how we're able to utilize fine-scale climate projections, risk data, hazard data, and so on, in what we have as our objective, which mainly relates to understanding, first of all, and then helping to address the population movement impacts or the migration impacts of climate change in the future. Just briefly some statistics. Last year, 24 million internal displacements took place around Asia and the Pacific. This is higher than the annual average over the last 10 years, which showed 177 million movements as a result of rapid onset hazards alone, things like storms, floods, landslides, and so on. We project, or there are projections that show that in a worst case scenario, up to 90 million people may be forced to leave their homes between now and 2050 due to slow onset hazards alone. Things like sea level rise, desertification, and other factors, right? What we don't know at this point is where these people live, who's most likely to have to move in the future, and where do they live now. Charles, you talked about how this data can become actionable. For us, this is key, right? If we're able to better identify where high-risk populations live now, we're able to put in place measures in partnership with governments, in partnership with scientists, in partnership ultimately with the communities, in order to manage these risks. In certain cases, hopefully preventing unwanted migration from occurring, and in other cases, supporting things like planned relocation, and so on and so forth. I want to make a point also as it relates to the relationship between advanced climate data and hazard data and the perspectives of communities. From our perspective, both are equally important. We have, very promising, ever-increasing granularity of hazard data, of risk data, of use cases for artificial intelligence and so on. And these are indispensable tools to better understand in a more granular way the risks that people face. But at the same time, there's no substitute for direct engagement with populations to understand their lived experiences, their histories, but also their desires. What may prevent them from moving, what may keep them in place, and what ultimately are the solutions that they themselves can lead to some of these challenges. So just to say, we see great promise already in the advancing sophistication, let's say, of hazard data, of risk data, of climate change projections, and we seek to sort of fuse this with community experience, community data, community lived experiences to help us address some of the challenges that people are facing as it relates to migration. Thank you.
Yes, I just want to say that Brad and I work together on the climate science side, but also the policy side of what you can do. I mean, for us, I guess, sitting in Hong Kong, displacement appears maybe just very temporary, right? Tai O may be flooded, but actually there will be millions of people all over the world, with many in Asia, that will be displaced temporarily, but some in the longer term on a permanent basis. So I think the science, what it can guide us to do in the short term, which is early warning, what might happen in the next few days, to longer term projection. The technology, how can that help us to deal with shorter and longer term issue? Sea level rise, again, in Hong Kong and elsewhere, what the risks are, shorter and longer term. So Wang, maybe I can now come to you. Being a financial center here, working with a bank, how does a banker look at all these physical risks?
Thank you, Christine. Yeah, OCBC as a second largest financial services group in Southeast Asia, we conduct regular climate-related risk materiality assessment in order for us to effectively identify, assess, and manage climate-related risk that may impact the bank. Yeah. This is in alignment with our established risk management practice and planning horizon. In conducting physical risks, we identify the property collaterals situated in vulnerable areas, such as flooding or tropical cyclone, based on the building address. Yeah. We evaluate the potential devaluation of those properties resulting from asset damage, shifting in consumer preference, as well as the consequences on the credit quality of the exposure secured by those collaterals. As we have been prudent in this area, I think that our collaterals situated in those vulnerable areas are limited. So the resulting impact from the physical and the transition risk are relatively limited as well. The financial impact to our bank is manageable based on our study. However, we also can tell over the longer term, such as 5 years and more, we start to see a moderate impact on the credit and operational risk. Beyond the physical risks, we also look at transition risks, such as shifting in consumer demand, rising cost of carbon credit, as well as the impact from climate-related risk. Because these factors may impact the customers' repaying capability. So we need to understand them better to support the customer's long-term financial resilience. Yeah. And in one key way for us to support the customer to manage the climate risk is through the transition financing. Transition financing is a critical evolution of sustainable finance. Green loans support those assets that those are already environmentally friendly. Transition financing goes one step further, which actually supporting those assets that may not be green yet, but we put them on the path towards a net zero target. Yeah. It's through the transition finance we can help the customer to upgrade their assets and improve the energy efficiency and to align them with a future carbon-friendly environment. One case we have here, which is demonstrate how OCBC use the transition finance as well as a green finance to support our customer in their sustainable journey. We completed a deal for a prosperity REIT last year. We are the sole lender and the sustainability advisor of this green and transition finance lending, which is the first in Hong Kong real estate sector. In this transaction, we are not just financing the green buildings of the customer portfolio. We actually using the proceeds to help the customer to bring the brown assets to green. Through this financing, the customer can upgrade their building, improve the energy efficiency over the 5 years period. And this also marks the first adoption of Singapore Asia taxonomy, which is the world's first multi-sector transition taxonomy, which is also featured in the information note by Monetary Authority of Singapore as a case study for the application of Singapore Asia taxonomy in financial or corporate sector. At the end of last year, OCBC Hong Kong, we have exceeded our sustainable finance commitment over 50 billion Hong Kong dollar. And we are awarded as the best sustainable finance bank in Hong Kong for 2 consecutive years by Global Finance. We are proud what we have achieved. Our commitment remains to build a sustainable future in Hong Kong, Greater China, and Asia.
Right, thank you. You know, you brought up the term transitional financing. So what you're really saying is you are lending for current needs, but actually you want your customers to transition to lower carbon, more sustainable. Debra, maybe I can come back to you because you have written, by the way, if you haven't read some of the reports by Debra, China Water Risk, do go and read them because you're quite specific, right, about specific property companies. Would you like to expand on that as succinctly as you can?
Right, Christine is laying it on me to name and shame some property companies. Right, I think, you know, hearing everybody's talking, it's very important to understand the urgency of fast melting ice, right? Once ice starts to melt, there's no undoing this ice melt. So we're only going to have to adapt more. So one of the key things is that we tried to sort of look at companies' climate strategies. I mean, IFRS standards are now becoming mandatory. We start off 1, 2 is physical risks, and therefore we're going to need a lot of these tools that Hong Kong UST is developing. Now, do companies have a cohesive climate strategies, or are we actually just looking at transition, adaptation, and physical risk completely separately? And so in order to sort of try to figure this out, we looked at the top 4 property developers in Hong Kong, Chung Kong, Asset Holdings, Henderson, Sungay, and New World. And we found, and we sort of looked at what they're disclosing. And we actually found that on the physical side, they're all stress testing for various risks. In Hong Kong, some of the biggest risks is typhoon, so they're all stress testing for that. 3 of them are stress testing for sea level rise, but not all 4 of them. Now, only one of their stress test description matched ours, right? I'm not going to tell you who it is. You have to go and read the report. Only one of those 4 companies.
So they're doing stress testing, and you are also looking at that.
No, because all these 4 property companies, and you've been to their assets, they're all pretty much next to each other. So 2 of them said, one of them said, I've got extremely high exposure to sea level rise and storm surge risk. One of them just said, I've got extremely high exposure to storm surge, but I didn't stress test for sea level rise. The other 2 said, I have no to low risk for all of those. So we're like, how come your spread is so different, right? So then we had to then do our own stress tests to figure out who is correct, and then basically only one of them matched. So why is it so different? Now, corporates are not expected to be climate scientists, right? You just pick a tool, you go with it. So sometimes you might have picked the wrong tool, so we actually don't know because you don't have to disclose which tool you used. So that's also another issue that needs to be covered. This means also that none of the risks are actually benchmarkable because they're all different, right? So this is just on the physical risk side. Then you sort of said, right, fine, you're very exposed, and actually all of them are very exposed. So you should actually be having adaptation strategies, and you should disclose those. So the one that sort of said, we are very exposed, in the chairman's statement also sort of said, therefore adaptation is very important. But then it doesn't really tell you exactly what they're doing. So it also doesn't give investors much leeway to sort of figure out, am I at risk, right?
Yeah.
But I would like to sort of say on the last note that none of them, so despite 3 of them having a net zero strategy and some of them being SBTI aligned, all of their emissions are still going up, which means their own physical risks are rising, right? And this also poses a problem for banks as well. So the other thing is that, with ice moving very fast and lifting all sorts of risks, not just sea level rise, but also weather patterns and et cetera, you have to start stress testing every year to the latest science.
So what you're really saying is this, because the ice is melting faster than people had expected, and it might melt even faster in future years, therefore, annual stress testing is important, right? If I can segue to the 2 scientists, wouldn't it be good? I mean, I know the work that you guys are doing, you're trying to be very specific. They talked about resolution, right? You want very high resolution. You want to be able to pinpoint, for example, where we are sitting in the middle of Wan Chai. What is going to happen on a bad day, right? Where you may have storm, you may have heavy rain and so on. So that allows you're creating actually new models. The point I want to stress here is most of us are users of models. Jimmy is a developer of models. What he tried to tell us just now is you're developing new models that should be much better for the tropics and the tropical areas. Why is it that the tropics and the subtropical area is harder to predict?
Well, because if you understand the physics, a lot of current atmospheric model is designed by the West, by US, and they are much higher latitude. When it is come to the tropics, because we are close to the equator, there's another force called Coriolis force. It's totally different. So that's why predicting tropic, the current model, will not going to work, especially for this extreme weather event. That's why a lot of these extreme events, we are unable to predict the intensity and the duration. Okay, so that's why we are developing a new generation of model, taking all these physical equation into effect in order to predict all these things better. Now, of course, you also mentioned about leveraging on the AI. Now, we are also using AI, but yet again, AI relies on data. Currently, a lot of the AI model rely on past data and then doing the prediction. But as pointed out by, one is we need to have a more accurate model predict what is the future climate so that we have the data to train the AI. The other thing is the AI rely on the physical model data in order to predict more accurately. For example, when the sea ice is continue melting, we may be reaching a tipping point where the whole world climate will be another regime, which we will never have past data to be able to train the AI model. So that's why you still need the physical model to try to predict, okay, when we are reaching the tipping point, okay, what will the future climate will be going to be like, so that we can continue to train the AI model. Yeah.
Yeah. Well, Charles, please. Yeah, I'm sure you have something to say about landslide.
Actually,
by the way, Professor Charles Wang is the king of landslide, not only in Hong Kong, but in the world.
Christine, thank you for kind words. And you put a lot of pressure on me now. But I'm not going to talk about landslide. I'm going to supplement my colleague, top scientists. And based on our observation, observation over the past 10, 20 years, what we find is the distribution of rainfall is highly non-uniform. Let me give you a recent example. It was raining like hell in Zhongguanou, but there was no rainfall in Mongkok. Okay. The overall average entire Hong Kong rainfall intensity actually is not increasing significantly, but is highly non-uniform. And that's why Jimmy's model has to be talking about precision. Otherwise, useless. We cannot evacuate entire Hong Kong people to mainland China. No way. Okay, we have to talk about precision. That's the importance of my colleague's work. Another observation is the frequency about the frequency of happening of extreme events. Over the last 30 years, we have studied that actually happened 5 times in Hong Kong, so-called 500-year return period. So much more frequent. Now, in theory, 500 return period means it's supposedly, statistically, supposed to happen every 500 years. But it's not the case anymore. That's why when we're talking about assessing risk, or talking about design, the concept of return period in some ways is useless. So that's why actually our team together, we have to talking about not just science, but also risk assessment and also prediction. And then we can have not just prediction, but also mitigation measures, and to help the industry, particularly insurance industry, to how do they assess their risk. And ideally, that's what we are thinking. If we can tell you the risk in, say, Wan Chai, over from 2 days ahead up to now, then I think that would be wonderful. Then the government would know what to do.
Well, that's what you're aiming for,
yes,
right?
Correct.
You want to aim to be able to give early warning to people about the risk as early as possible.
Yes, and also function of time.
Maybe in a few days,
yes.
More accurate. Okay.
Yes. Yeah.
Before coming back to Ma Qing and Wang and Debra, maybe I want to just come to Brad. I know you are now trying to work with actually scientists, right? People like Charles and Jimmy from Asia. Tell us a little bit about why you think this is so important for you to work on the science aspect.
Yeah, thanks for the question. So exactly. I mean, we've been working together on this exact issue. For us, okay, first of all, the promise of science, everything that's been discussed today, the work that Charles and Jimmy, HKUST, and many other universities around Asia, around the Pacific are doing on this topic. How can that be utilized to support populations that we're concerned with, those who are the most vulnerable, for example, those who do not present in any real way bankable opportunities for adaptation finance and so on and so forth, really beneficiaries of public finance in effect, right? But it's also about ownership, let's say, national ownership and local ownership. It's a fairly straightforward proposition to have an expert consultant fly in from Europe or the US or outside and create a model, a risk model, or a hazard identification, and so on and so forth. It's something else to work directly with institutions who are concerned by the issue, who have knowledge of the country and of the society, and ultimately will be part of the design and implementation of a solution. So we focus a lot of energy and time now on what we call co-creation. It's a little bit of a cliche, but we really try to make it work. This means institutions from the region working with institutions in the countries concerned, both to cross-fertilize scientific knowledge, but also to co-develop and ultimately co-implement solutions for people in the communities most impacted that they own, that they drive, that they are comfortable with. So our role with the UN is to facilitate this exchange, to facilitate this process, to bring together different universities, for example, different scientists, people from the finance sector, and so on and so forth, in a way that can drive at scale effective solutions to the problems that we're trying to address with my agency.
Ma Qing, perhaps I can come back to you and maybe you can share a little bit more with us on the technology side.
Sure, happy to. Well, we talk, today we also talk a lot of data centers, right? So data centers consume a lot of energies and heat. Again, here we have technology enabled by AI that are having a cooling optimization system that we also use and collect all the data, real-time data from the sensors that we installed in the data center, the whole system, and then automatically to optimize and distribute the cooling into the lowest level of the energy consumptions. So I think that's also support a lot of how we save energy efficiency around about 30-20%, but also really help hugely the energy resilience. And speaking for, we talk a lot of rainfall, right? So, and also the extreme weathers in Hong Kong, for example, the harbor workers can be exposed to risk at the unloaders, right? So actually we also use AI-enabled solutions to do the automatic unloading solutions so that we keep the workers from working on site and at high risk to indoor and remote solutions. So again, you see this is also a little bit, the technology eventually has a purpose to keep people safe, right? So that's another example. And in the rainfall situation, we know the sewer system is very crucial because otherwise it could also result in overflow, and some of the untreated sewage can be released. So for protecting that, we also use AI to collect and analyze the rainfall data so that we learn from the data how the pipe normal behavior looks like. And based on that learning, then we develop solutions that we hope that we are we aim not to have the flood or the pipe that is blocked, so that we can also keep the clean water from the retention. We talk about digital twin technologies, and digital twin actually is also do a lot of, it is used in all kinds of scenarios across industries. And digital twin, for example, can simulate scenarios and analyze the situation and predict failures, and also identified options. When stock is hitting, for example, storm is hitting the infrastructures, that the digital twin can exactly identify what is the impacted areas, and then also provide tested options, and also provide the recovering options and measures. So that's what we see, how technology is helping in all these kind of situations.
Right, I'm sure that Siemens and company like Siemens, maybe working with the universities, these ideas of digital twin, I'm sure for many of the companies here, you may, whatever area of work you're in, you may be building digital twins. So for example, at HKUST, we have digital twin of the entire campus. But Debra, you wanted to say something, so over to you.
In my old age, I've kind of forgotten what I was originally going to say, but I am going to make a comment on digital twins. I think, the thing about fast melting ice, it also affects our rivers, right? The Himalaya water towers is a huge storage of fresh water reserves. And it's also melting faster now, which means we're going to see more water and peak flow by 2050. Now, China's also mapping all its rivers and doing digital twins of all its river basins, because there's going to be more water, more floods, more rain, and so forth in the coming years, right? And to Jimmy's point and also Charles's point, if we see a small shift in the underlying cryosphere, we could see huge shifts in extreme weather and so forth, right? because we can't forget that the ice is actually 2/3 of our planetary tripping points, is the cryosphere, right? And just to give you an example, say 1 meter of sea level rise, which will cause 200 million people in Asia, which will affect 200 million people in Asia, and who knows where they will migrate to. If we just have 1 meter of sea level rise, which could happen now on our current trajectory, anytime between 25 to 45 years, depending on where you are, that's in the time horizon of an infrastructure project or a real estate project, right? Now, if we have 1 meter of sea level rise in Hong Kong, we will have close to every day we would face a minor flood. And by comparison today, that number is maybe 1 minor flood, right? And we would face a major flood if it was just 1 meter of sea level rise, pretty much like at least once a week, right? And under the definition of a major flood, we face no major flooding today. So can you imagine in 25 years, 1 meter of sea level rise, we could be facing 1 major flood every week at least, right? And 1 minor flood every day. Imagine the amount of heavy lifting that we will have to do to step up adaptation to sort of like sort that out, right? And the amount of financial damage that would cost. So we really, starting from today, need to work together, like this whole row here, right? The scientists, the tech, the bankers, you know, and also the software, you know, like getting people ready. It's not just about building cement infrastructures. It's like, how do we get people to prepare, right? How many of you knew what to do during a black rain, before the black rain happened, right? Yeah, none of us. I was like, I'm stuck here. What should I do? Right? Oh my God, there's landslides.
Stay home.
I should stay home,
Stay
right?
home.
Yeah. I know what to do in a typhoon, but I didn't know what to do in the black rain until it happened, right? We need to start practicing. If we're going to get an alert saying, you know, evacuate now for landslides, do we know what to do? Not really, right? This takes time to learn and educate and so forth.
I think the thing is, you know, sea level rise, we can kind of map it out. And Jimmy, one of your slides showed us that by 2040, 2045, how many hot days we already have in Hong Kong. And I think part of our problem in Hong Kong and in the tropical areas is we're used to heat. And many of us are used to rain. So we perhaps are less sensitized to what this really means. And you know, when scientists tell us about 2100, and I think, well, I'm dead, right? You know, so I can't really cope with that thought. But actually, 2040 is not that far away. So Wang, maybe I can come back to you, right? As a banker, financier, maybe some long-term finance for projects. How do you really, for example, real estate, right? And some of the major industry. What are you doing?
Thanks for the question, yeah. I think OCBC as the longest established bank in Singapore, right? We fully recognize our financial success is inherently linked to the overall health of the markets we and our clients operate in. So in near term, we expect our customers to meet the minimal standards and ensure them they do no significant harm. In the medium and longer term, we want to use the sustainable finance to help the customer to accelerate their transition journey. Yeah. If the customer does not engage in a credible science-based decarbonization plan in a good faith, we may re-examine the relationship. Especially,
so you're pushing them, right? You're telling them, if you don't have a transition plan that the bank is happy with, you might not do business with them.
Yes, especially given the transition risk is growing with the evolving economy. Yeah. We also take the ESG risk into the consideration in the long-term success of the bank as well as the communities we operate in. Yeah. We expect our customers to meet the local ESG law and industry standard in the near term. And as the market evolves, right, and adopts sector-specific standard, we also expect our customers to align with those global benchmarks. Yeah. We will not engage or knowingly finance any activity where there is clear evidence it may cause unmitigable damage to the community, to the people, or to the environment. Yeah, and as the climate-related risk grows and the cost and regulatory expectation evolves, I think a transition to net zero is no longer an option. Organizations must act decisively to cut their emission and the transition, start the journey to a transition to a net zero future. As a bank that is accelerating our transition to net zero future, we want to work closely with our client to positively steer the behavior of our clients. Right? It's we will engage and support our clients on a risk proportionality basis to ensure they adopt more sustainable practice. We value the long-term relationship, so it's important not let our clients behind. As the transition to a net zero future is a complex challenge that requires inclusive and practical support. We remain partner with our clients in this journey in line with the Paris Agreement, which means we give the customer reasonable timeline to meet the relevant expectations. However, if those expectations are not met, again, we'll re-examine the relationship, including decline future transactions or exit the relationship altogether. We remain committed in this journey, and we want to partner the customers which is sincerely embarking the transition to a sustainable future. And the sustainable finance is a versatile tool, can really be tailored to customize to the very specific sustainable target of our corporate client prioritizing and supporting them to make a meaningful progress in those areas. Yeah. I think one great example in how we use the sustainable finance to support our customer in this is a sustainable linked loan we completed with a non-Fung group, which is a private conglomerate with a very strong real estate portfolio in Hong Kong. Based on the research, right, the landlord and the property management company may not be able to overcome the challenges in achieving net zero by themselves. Yeah, because the scope 3 emission for the landlord and property management, about 85% of them coming from their tenants. Yeah, occupied by their tenants. Yeah, it's so for us. So when we talk to the non-Fung, actually is we understand the renewable energy and engaging their tenants in this development. Their key sustainable strategy. So that's how we develop this sustainable linked loan to really supporting them in achieving those sustainable targets. Yeah.
Great, thank you. Well, let me round off. You know, we get a bit depressed by the science in terms of how bad it could be. We know that if not us, then our children are going to still be there. 2040, 2045, actually for all of us in this room, it's just round the corner. We depend on the climate scientists to continue to help us. It's bankers and technologists, the UN, actually they are more interested in the development of the climate science itself, which I think is something quite new. We're glad that climate scientists are able to do quite a lot, but probably we need to spend more time together to see how this range of knowledge can help each other. We have magnificent technology companies all around the world, including in Siemens, lots of technology that can help us to run our cities better. We have bankers who are actually quite activist They are actively telling their customers, we may not take you if you're not willing to transition. Sea level rise is a problem for all coastal cities all across Asia. And I think at the UN level, you are concerned about vulnerable communities, large populations of people that will be displaced temporarily, but many permanently. So in Hong Kong, we are grateful that we have a chance to work with everybody. And I hope that you have enjoyed the session. Please put your hands together for the panel.